Hi, this video is about dynamic memory allocation. Basically, dynamic memory allocation is when you increase or decrease the size of the memory used by your program during runtime. Let's see an example. Uh, Here we have an integer of uh, 10 elements, 10 integers, whose name is ages. I am going to um, collect 10 different ages, okay? But let's now consider the following case. What if I was collecting ages and I end up with a total of 20 ages? So in that case, this array will not be suitable for that task because it has a fixed size of 10, okay? So uh, I will I wish my program could grow the size of this array in order to accomplish the collection of new of a larger number of ages. Okay, so this can be achieved by the functions from the C standard library. For that purpose, uh, we will see what are the functions, and we are going to basically allocate additional memory space during runtime of our program. So uh, in that way, we won't need to um, specify a larger size here and um, compile it again. But instead, during runtime, we can increase the memory size uh, depending on what we need, okay? Basically, we are going to request the memory from the heap, which is this memory layout from the C program, and we will access this memory space through pointers pointing to that addresses, okay, in that part of the memory of our computer. Basically, we are going to use this stdlib.h header file that will provide these four functions for dynamic memory allocation. So the first one is here you have the function prototypes. So the first one is malloc, which will take one argument, which is the size of the data type that we are going to store. In the previous example, we had an array of 10 integers whose name was ages. So for that purpose, we will have to use size of integer, okay? And it will return a pointer to void, which means it will return the address in which now I can uh, store this newly created um, integer, okay? Basically, Malloc will allocate memory for a single datum of the specified type, and it will return a pointer of type void. The initial content or value of that memory allocation is garbage value, okay? So one single element and initial values garbage, okay? Then we will use the function calloc, which will take two arguments and will return also an address, a pointer to void. But let's see what's the difference. Whenever you call calloc, you will have to provide two arguments. The first one will be the number of elements that we want to store, and the second one will be the size of the data type of those uh, um, uh, data that you want to store. Okay, so first here I write how many elements. So let's say in this case for ages I want to store 10 elements, and which is the type integer. Okay, so we will have to specify here the size for an integer and the number of elements, in the previous case 10. Okay, and this will return an address of a memory block that contains space for 10 integers. So basically, calloc will allocate memory for a block of n data of the specified data type. So several elements, not just one like in Malloc. And they will be initialized to 0. So this is clean memory block, unlike this garbage value for Malloc, okay? And we also have to do a typecast because this functions return pointers to void, which means address, but those addresses do not specify which data type is going to be stored there because it's type void. So depending on the data type that we are going to store, we will specify to uh, read this address returned by those functions as a address for storing a particular data type. So for instance, for storing double or integer or whatever. I will show you in detail in the next part. Um, then the third function is realloc. Realloc will take two arguments. The first one is uh, the name of the memory block, and then an integer, which is the new size. Because basically realloc will grow the size of the current memory block. So I specify here what's the memory block name and which is the new size that I want to resize that memory block. It can be more or less. And it will return a pointer, an address again, okay? So it is because the address may change. So let's say, for instance, that I'm in a certain position in memory and I want to grow the memory block forward, okay? But whenever I hit the forward spaces, I will find some other locations that are being used or not available. So for that purpose, I will have to maybe go to another different location. But the advantage here is that I will keep the same previous data that I had in that memory block. So let's say, for instance, that for that array of ages, I had written already these 10 ages, but now I want the size to be 20. So I will keep the first 10 ages, but the new size is going to be 20. So I have uh, um, 10 additional spaces. Okay, so realloc will basically allocate larger space for the memory block specified in the first argument here, with the new size specified as in the second argument, keeping the old values. Okay, and free is the function that we call whenever we want to free the memory allocated by these functions. Okay, so whenever we are not using these contents anymore from that memory block, or we are finished our program, we will call free, and we will pass in this argument the name of that memory block. Okay, so in this case, for instance, we will say free ages, which is the name of this array. Um, Now let's do here a simple example before we go to our example codes. So just as I told you, whenever we perform dynamic memory allocation, we are going to call these functions that will return a pointer, an address to that memory block allocated. So in order to collect that return value, we will need a pointer. So the pointer must be of the same type of the data type allocated. So for instance, we were allocating integers in that example of 10 ages, okay? So for that example, I will use a pointer to integer. Just like in here, I name it PT. But we could be using pointers to doubles or pointers to structures, depending on what's the data type that we are going to store dynamically. Okay, now let's store one single integer. So for that purpose, I will use malloc, remember. So malloc size of integer. So get me one integer, okay? One space for an integer. And since it will return a pointer to void, we will need to cast it. That is, we will use these parentheses here, and we will place inside the data type that we want to interpret from this return value. So this is the address returned that allocated one single integer, and we must cast it to pointer to integer, okay? Because pt is pointer to integer. Now we are going to allocate 10 integers. So for that purpose, we will use calloc. Remember that calloc needs two arguments. So the number of elements that we need, in this case 10, and then size of the data type, in this case integer. Okay, so get me 10 spaces for integers. And remember, we cast it to pointer to integer here. And now we are going to resize that pt memory block. We are going to use realloc, and I'm going to specify here what's the memory block to be resized. In this case, I am stating here resized pt, and the new size is 20 integers. So this is why I'm multiplying the number 20 by the size of an individual integer. So please resize pt to store 20 integers, which is the second argument, okay? And whenever I'm finished using those memory allocations, I am not using here because I went I just using this as an example. But whenever I'm finished wherever writing or reading operations to this memory block, I will use the free function. I will pass the name of that memory block to be freed, which is in this case pt, okay, to make the function available for my operating system. So remember, malloc, just one single element initialized with garbage value. Calloc initialized an array of elements of the same type, and it initializes them to 0. Realloc will reallocate, will actually resize my memory block, and it will keep the old contents. And free will release that memory block. Okay, now let's do the practice codes. All right, let's now start with this include statements. We will need stdio.h, stdlib.h with the memory allocation, dynamic memory allocation functions, and this string.h because I'm going to manipulate strings in some examples. So first of all, I am going to allocate integers. So remember, I will use a pointer to that data type that I'm going to store, in this case pointer to integers. Remember that these functions will return pointers, so this is why we need to collect them in pointers to the specified data type. So let's first start with malloc. Let's allocate just one single integer. So I will call pt equal to the address returned by malloc. So let's call malloc, and remember, I will have to pass size of integer type. Okay, but remember that I also have to cast it. So that is, it's going to return a pointer to void, but this must be interpreted as a pointer to int. This is why I cast it here to pointer to integer, because pt is pointer to integer, so it can only store pointers to integer type. Okay. Okay, what else? Then we are going to print here the value, which is garbage value. the argument here is pt. Remember that we'll have to dereference this value in pt. The value here seems to be 0. Okay, now um, let's give pt a value. So I'm dereferencing here this thing to access the value, and I'm going to give it the value of 15. Okay, there's no problem with this. But now I will do an array of integers. Okay, so for that purpose, I will now call, I could do realloc and pt, which is now of size 1 integer. I could use realloc and resize it to different size. So for instance, 2, 3, 4, 5, wherever I want. So I could use realloc, and remember that realloc will keep the previous contents, in this case 15. So let's do the following. Now pt is going to be the memory block returned by realloc. Okay, so remember that realloc will need the memory block that I want to resize, which is in this case pt. And what's the new size? The new size will be, let's say 2, just 2, for the size of, here, the size of integer. Okay, and also remember that I have to cast it to pointer to integer. So pointer to integer cast. Okay, and now how I'm going to access this? Okay, then I will have now an array, because the first place I had just a single integer. Now I will have 2 integers, which means an array of two integers, and I will read pt 0. Okay, let's see if it works as suspected. Remember that I will use this index here to access the pointer 0, which is supposed to be 15, which was kept unchanged by realloc. As you can see, it worked. And I'm going to print wherever is next in the integer array. So pt1, which is the last element of the array. 0. Okay. Now let's delete this thing, and let's suppose that I am writing this. Okay, now I'm going to use pt to allocate several integers. So for that purpose, I will use, remember, calloc, and I'm going to make an array of size 5, and here size of integer. So it will allocate 5 elements of type integer. Okay, remember that the first one is the number of elements, and the second argument is the size of that data type. And remember to cast it to pointer to integer in this case. And all the elements should be 0, initialized to 0 by calloc. So let's print a few of them. Okay, let's hit run, and all of them are 0. I printed here the 5 elements. However, I'm going to use this one, pt, and let's say a random location, pt3, and let's load the value of 100, and let's print this thing again. We'll have 0, 0, 0, 100, 0. Okay. Now I will change the data type and I'm going to use a structure. Struct student, and I'm going to semicolon here. Let's use int age, double average, and then chart name. Okay, we will have like in previous examples of other videos, a struct of type student which will contain the age, the average, and the name of that student. Okay, now I'm going to use a pointer in this case, which is not a pointer to integer, but instead will be a pointer to struct student. Okay, so it means that I'm going to allocate structures. Okay, so let's allocate first with Malloc. Remember that Malloc will take just only one argument, in this case size of the type, which is in this case struct student. I am not creating here the actual structure. I am creating just a pointer to structure. So it will store the address that should be of a type struct. Okay, so it's not the structure itself. The structure itself will be allocated here with Malloc. Okay, and I'm going to cast it here to the type, which is struct student pointer. Okay, so you can see I'm always keeping record of what's the data type of that pointer to be the same here. Okay, now Malloc. Okay, and now I'm going to use, I can use this thing because PT doesn't exist now, but I'm going to use, oh, okay, also I forgot to mention that it's very useful and important that you check if that pointer returns an actual address or if it has a null pointer. So because it is trying to allocate in memory data type. Okay, but if it the data sorry if it returns 0, it means that memory wasn't allocated. So if I use this if statement here for PT, I will check if the pointer is 0 or if it does actually store an address, an existing memory location. Okay, so basically I check this pointer for not being 0, and in case it is not 0, I can assume this memory was allocated successfully somewhere in memory, okay, with some address. So in case memory was allocated and this PT is not 0, I will access the structure members. So in this case, PT pointer to structure and age equal to 20. Remember that we've seen this in structured videos. It's just when I am accessing members of the structure, but I am using a pointer to structure rather than structure itself. So the next one is PTAVG. It's going to be this one, I guess. And then remember that I will have to use strcpy, which is why I'm including here this string.h. And the destination is pt name, and the source. Okay, I'm going to write here John Doe. So it will transfer these contents of the string John Doe to the pt name here, okay, this array. Okay, and I'm going to print all the structure members one by one. So here pth, the next one is long double, sorry, abg. This thing is wrong here. Okay, and now the name, which is a string. Okay, name. Okay, and if I did all of these operations, I forgot to use the free function, so sorry for the former examples. I will have to free pt. Okay, as you can see, I allocated this in memory, and I wrote these values successfully, and also I was able to read them successfully. Okay, now for the last example, we will use calloc function, because I am going to allocate now an array. So for that purpose, I will need to change these arguments here to be 2 arguments. So this is the number of elements of my array of struct student. In this case, I will have an array of struct students, which contains 2 structs, 2 positions. And what needs to be changed here? Okay, if pt is not 0, it was allocated successfully. I will use this. I will have to change this pt to this index here, because it's now an array, and then I will use the normal dot operator. So this is how it changes. Okay, let's replace this arrow operator here. This is the first position here. Sorry. Then this one here again. Okay, let's hit run, and I have the same, but now I am going to also write the contents of the second the second element, the second struct student. So for that purpose, I will copy this again. Let's change the index to be this one. Now let's change the age and average. And name, let's say now Mark Johnson. I don't know. Johnson. Wait. Okay. And now I will have to print it. Change the index. Let's print it. Okay, here we have this John Doe and this other guy, Mark Johnson. And finally, let's do a realloc. Oh, okay. Well, let's use this free. Let's remove it from here. Place it at the end. And let's use the sprint f in another place, because we'll leave them at the end for printing at the end, because in the first place I allocated just 2, struct student in this array. And now I am going to use pt with realloc. So let's copy this thing. So I will have to change just this part of realloc. This is the size. Now I have to specify the new size, and it's going to be 3 multiplied by the size of, an individual struct student structure. And here it's going to be the memory location or block that I'm going to resize, in this case pt. So basically realloc will resize pt to be now three elements of type struct student, and we will place that block, that address, as the new address of pt. Okay, it could be the same address, or in case that it didn't found the same just amount of memory in contiguous locations, it will place all of those previous contents into a new location, which will have these 3 positions of array of type struct student. Okay, so let's now do the following. Now that I have this, I know I will keep the old contents, but now let's check again that pt was allocated successfully. That is not a null pointer, and in case it is, we are going to write the 3rd position. Sorry, this is the right index, number 2. And then let's change this, let's say 23, and let's say different average, and let's say Randy Olsen. And now I'm going to print again. Let's change the indexes here. Okay, now let's run the code. As you can see here, we have John Doe, Mark Johnson, and Randy Olsen. Okay, now I'm going to do a different example. For that purpose, I will use a pointer to character, and I will name it, I don't know, text. Okay, and now I'm going to, for text, I'm going to allocate memory. For that purpose, I will call Malloc, and I will request 20 bytes, because I'm going to store up to 20 characters, okay, of text. So remember, size of char, okay, 20 characters, an array of 20 characters. And remember to typecast this pointer to character, because text is a pointer to character. Okay, and now I'm going to use the strcpy to copy to this text memory block the following contents. Let's say, for instance, Sarah Johnson. Okay, I guess we still have some space left, so I'm not using more than 20 characters here. This is okay, okay? All right. Remember that we could do a check that text is not a null pointer. Let's point to an actual memory location of this size. And now we do that. Also, I can print the contents of text. All right, let's see. Okay, Sarah Johnson. But now let's suppose that I want to store a longer text, a longer string. So for that purpose, I will use now whenever I'm finished here, I'm going to use the reallocate function. So remember to typecast to pointer to character. Let's call reallocate. And let's now resize text to a maximum size of in this case 100 characters. Okay, so size of car. Okay, so we're basically resizing this text array of characters dynamically allocated to be of size 100 characters. Okay, so I'm doing this now. Remember that reallocate will keep this previous content, so we have here Sarah Johnson, and I'm going to check if text is not a null pointer, then proceed and do the following. I am going to append to this Sarah Johnson another string, and I will use from string.h and the function string cat string. It will concatenate this previous content, Sarah Johnson, with the another string that I specify here. So I will use in this case text, and I'm going to include this trailing string. Sarah Johnson is 30-year-old teacher at high school. Okay, and now I'm going to print again text when finished. Okay, now let's see if it works as suspected. Yes, it does. As you can see here, the first one is Sarah Johnson, then we use the reallocate to resize it to a larger size, and then we use this string concatenate a string cat to append these new contents. Is at their 30-year-old teacher, blah blah blah. Here, okay, and we finish by printing again the contents of the entire new text array of characters. Okay.